It's easy to get caught up in the flashy algorithms and wild predictions of machine learning. But the real secret, the actual magic behind powerful ML, isn't just about the math, it's about the journey that the data takes. So today, we're going to follow that path, step by step, to see how raw, messy information turns into a game-changing insight. Let's jump right in. So let me ask you this. What do you think is the single most critical step in any machine learning project? What's the one thing that can completely sink the ship before it even leaves the port? It's probably not what you think. And honestly, getting this part right is the difference between an amazing success and a total failure. Okay, first up, let's talk about the big picture, the machine learning pipeline. And the most important thing to get your head around is that this is not a straight line. It's really a continuous journey, a loop of learning and getting better. It all really boils down to 3 core stages. First, we have to generate and prepare our data. This is the fuel for our entire engine. Next, we use that nice, clean data to train and evaluate our model, basically teaching it to spot patterns. And finally, we deploy it out into the real world, and we monitor how it's doing. But here's the crucial part. What we learn from that monitoring stage, it feeds right back into the first stage, the data generation part. This creates this incredibly powerful feedback loop that just makes the whole system smarter and smarter over time. So let's dive into that foundational first stage, preparing your data. This is where all the hard work happens. This is where we literally turn chaos into clarity. Data flows in from everywhere. It could be historical records sitting in a data lake like Amazon S3, or maybe live feeds coming in from APIs, or even real-time streams of information. But no matter where it comes from, almost all of it shares one unavoidable characteristic. And here it is. This is the unavoidable truth. Raw data is, well, it's messy. Just picture a data set of real estate listings, right? You might find some house prices listed in dollars and others in euros. You will probably have missing zip codes, weird extra spaces, or just plain wrong information. And this isn't some rare exception. This is the rule. This is just how data comes. So, how do we fix this mess? Well, we have to tackle each problem head-on. For those inconsistent formats and the not a number, or NaN values, which are just placeholders for missing numbers, we have to standardize everything. For missing entries, we might fill them in with a good guess or just remove that row altogether. And for duplicates, we either merge them or get rid of them. Look, it's not the most glamorous work, but it is absolutely essential. In fact, you'll hear data scientists say that this phase alone can take up to 80% of their time on a project. 80%! All right, so once our data is clean and organized, we get to move on to the fun part, the detective phase. This is where we start exploring the data to uncover the story it's trying to tell us. This whole process has a formal name. It's called Exploratory Data Analysis, or just EDA for short. And its purpose is actually pretty simple but incredibly powerful. We're hunting for patterns, for relationships, for anything that looks weird or out of place, and we're doing it before we even think about picking a machine learning model. This initial investigation is what helps us form a hypothesis, and it guides our entire strategy. And just like any good detective, we have a toolkit. We use things like charts and graphs to literally see the patterns. We use statistical summaries like the mean or median to get a feel for the data's center. But one of the most powerful tools in our kit, especially for finding those hidden connections, is something called the correlation matrix. It helps us put a number on the relationships between different variables. Think of a correlation matrix as a cheat sheet for understanding relationships in your data. It's basically a table that shows you how different variables move in relation to one another, and the scores tell the whole story. A score of 1 means they move perfectly together. A score of -1 means they move in a perfect opposite direction. And a score of 0, it just means there's no straight line relationship between them at all. Okay, let's take a look at this quick example. The diagonal going down the middle is always 1.0, because a variable is always perfectly correlated with itself, right? But check out the relationship between price and square footage. It's 0.85. That's a strong positive correlation. It tells us pretty clearly that as the square footage of a house goes up, the price tends to go up too. Makes sense. Now, what if we had a variable like, say, distance from downtown? We'd probably expect to see a negative number there, maybe a negative 0.7. Why? Because as that distance increases, the price would tend to decrease. That's a negative correlation. Okay, now, For anyone studying for a certification exam, I need you to listen very closely to this. This is critical. You do not need to know how to calculate this by hand. You just need to know when to use it and why you're using it. You use a correlation matrix during EDA to figure out which of your variables are strongly related to the thing you're trying to predict, in our example, the price. This insight is what helps you choose the most impactful features for your model. And knowing that this is a feature selection tool for EDA and not a model evaluation metric, that's a super common exam question.
So let's bring this all together. Let's put on our exam taker hat for a second. The real key here isn't about memorizing a bunch of terms, it's about focusing on the process.
So here it is, your exam checklist. Number 1, data preparation is the foundation. Remember, garbage in, garbage out. It's as simple as that. 2, EDA is your detective phase. It's for finding insights before you build anything. 3, you need to know when and why to use a tool, not just what the tool is called. And finally, number 4, always keep that full cyclical life cycle in your mind.
And I really want to leave you with this final thought. It's so easy to get lost in the weeds, to get fascinated by all the complex math and the fancy algorithms. But I want you to always remember this. The best models, the most successful, most robust, and most reliable models, they are almost always built not on the most complicated math, but on the cleanest, most well-understood data. Master the data, and you will master the model.